Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to present about our presentation about the LAB5. So for the LAB5, the title is Filter Design and Application. So first of all, let me describe a little bit about what is filter. Filters are data processing techniques that can smooth out high-frequency fluctuations in data or remove periodic trends of a specific frequency from data. Um, the goal of filtering is to perform a frequency-dependent alteration of a signal in many systems, and also filters are used to remove noise from a signal. So next is um, biquad design filter. The biquad filters allow for custom low pass, high pass, or any other desired frequency shaping of the signal. By default, the frequency response for each biquad filter is an all pass filter, meaning a frequency response with a flat gain of 0 dB. The next is notch design filter. The notch filter is a combination of low pass and high pass filters similar to the band pass filter design, but the difference is that we connect both the filters in parallel connection instead of cascading connection. In this lab, the desired filter can be designed in several different ways, providing a different amount of flexibility for future modification. Okay, before we starting any of filter design, you should carefully characterize or identify the signal to alter. This will allow the the creator or the who choose the filter to determine the filter configuration to be used. For example, the goal of a particular filter might to remove noise a certain cut-off frequency. So in this case, a low-pass filter might be used.
Okay. Assalamualaikum. My name is Nur Azali bin John. So for this assignment, we are doing LAB 5 backward filter design task 3. Okay, so backward is in signal processing digital backward filter, second order recursive linear filter containing two pole and two zeros. Okay, for this lab, we are using mystery signal 1. So the hertz is 22,000 hertz and a bit 32-bit mono. So we set up a spectral analyzer, two spectral analyzer, one for not filtering the noises and two after we using a backward filter. And then we set up switches. Switches function for switch from direct signal and filtered signal. So we use one audio stereo output. So after we run, we can simply switch from raw signal and filter signal. So we need to construct the circuit below. Okay. This is the spectrum analyzer for backward in lab 5. So as we can see here, for spectrum analyzer, spectrum analyzer 1 is the signal that not filtered by any filter. So we can see the wave or audio wave over here is many distortion, not filtered. Very noisy wave. And we can see other side spectrum analyzer, the signal wave is filtered at the end. So the noises is not at the end. And then we need to improvise the lab to make assignment. So we're using the task tree to improvise as a assignment. Okay, here what we improvise. So I'm telling you that we're using another output source. Let me play first. Okay. Oh, this is for the task tree experiment. So we're using 22,000 hertz signal. Then we run it. As you can hear, the noises is very loud because the bicep signal cannot filter as much noises in this source. Okay, done. Next. Okay, this is not filtering design. I passing to Farriez Iskandar to present.
So my name is Muhammad Farriez Iskandar bin Abdul Aziz. I'm from section 1-2. So for this assignment, we are using LAB5 to complete our assignment, and my part is for the notch filtering design. Okay, so this is the circuit that we use in LAB5 for subtopic or task number 4. It is notch filtering design. So what is a notch filter used to? So the notch filter can be used on the common for a fixed frequency noise source, such as from the line frequency noise. Okay, and then notch filter also used to remove resonance from the system. Okay, so at lab 5 we already done this exercise. As we can see, as the source, we change the input to the mystery signal 1. Okay, and then there are uh, some item that we use, such as notch filter, and then the spectrum. Okay, the spectrum, and then the audio output and switch. Okay, so this is how we connect the circuit. Okay, the first spectrum analyzer is uh, after the source, and then the second spectrum analyzer after we filter for output, and then the switch on and off for the notch filter, and then the output audio. Okay. Okay, so next we can see the spectrum analyzer for notch filtering design. So the first one is spectrum analyzer. We can see uh, the spectrum analyzer on the right side is before the filtering process happen. So we can see that there's not much uh, there's not much difference between two of these. Okay, but we something that we get is the spectrum analyzer after the filtering process a little bit different. So because the notch already cancel some noises from the audio output. So this is the video for notch filtering design in lab 5 that we have done.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric.
Okay. This show that notch filter design is one of the good filter or suitable filter that we can use compared to because big quad cannot filter as much as how the notch filter does, so the sound is very clearer and better than big quad. Okay, so for simulation for big quad filter assignment that we does, I will pass to Azalie Jone.
Okay, this is for simulation by quad filter that we improvise using different source and same method that we need to upgrade in notch. So we're using 48,000 hertz, more higher than the LAB. The LAB only 22,000 hertz, but in this simulation we're using a different source, which is 48,000 hertz. So we're using the same bi-quad filter and two analyzer, spectral analyzer and manual switcher. Also we put mono audio devices. Okay, then we run on it. As you can see here, in this spectral analyzer on the right, which is the output that not be filtered. We can see here so many noises that not filtered by backward backward filter, and the other side is a waveform that source filtered by backward filter, and not much different we can see here because the backward filter cannot filter the high pass wave or high pass band. So we hear the voices and look at the simulation. So here the simulation. We put the different source, which is our source, 48,000. And then we run.
Assalamualaikum and good morning. Today we are testing for DSP assignment. Assalamualaikum and good morning. Today we are testing for DSP assignment.
As we can hear, not much different from the original file. Because in simulating, a backward filter was used to build the low pass filter, and spectral analyzer placed before and after filter to see the differences. The low pass filter MATLAB coding was transferred to the backward filter. The low pass filter allow audio and noise to pass through while preventing high frequency noise. So the backward filter not filtering the high frequency, only filtering the lower frequency. That's all for me. And then for simulation notch filter, I passing to Farriez ESKANDAR.
Okay, so this is the simulation that we do for notch design filter. So this is the circuit that we have done. It is different between the LAB5, so we use our own sound, and then the frequency is changed here, 48,000. If the LAB5 that we use is only 22,000. Okay, so this is the input for this circuit for notch filter design. Okay, so next part is the filter. Okay, so the filter that we use is notch to peak, and then we use peak one. Okay, then two spectrum analyzer, so we can compare between after filter and before filter. Okay, so the switch for on and off the filter, and then the audio output. Okay, so this is the spectrum analyzer for notch design. As we can see here, the noises, this is the spectrum analyzer one that is connected before the filter. Okay, on the right side is the spectrum analyzer that we connect after the filter, the notch filter. So there is the difference between the two spectrum analyzer. Okay, so as we can see in line 20, between these two analyzer, we can see that before filtering it is uh, negative 100. Okay, and then but here on the spectrum analyzer on the right side, we can see it is only at negative 120, and it is going higher and higher. Okay, so which means there's a noise cancellation for the notch filter that we made. Okay, so this is the video of we running the we simulate the circuit. Assalamualaikum and good morning. Today we are testing for DSP assignment. Assalamualaikum and good morning. Today we are testing for DSP assignment. Assalamualaikum and good morning. Today we are testing for DSP assignment. Assalamualaikum and good morning. Today we are testing for DSP assignment. Okay, so as you can see here, for the first one is we are using the we point the filter at the notch point. So this is the output that we used to get. There are many noises that we gain. Okay, so at the notch peak, uh, at the notch peak filter, if we are using the notch point, we cannot get a clearer sound, and then we change it to the peak one. Okay, if we change to peak, okay, you can hear that the sound is clearer and better than the record and the notch. But we also get that this filter also filter the voice from the sound. Okay, I play again. So there is no noises that we get. Okay, but this notch filter also let the volume of the sound becomes lower, but it is in better condition. Okay, so after we are completing this assignment, we can say that notch to peak filter is a better filter that we can use to get a better sound. Okay, that's all from me and Azali. Thank you.
For the conclusion, for me, I can see that notch is more suitable to use than biquad filter that being shown by Azali and notch by Farriez Iskandar, because notch already cancel out the noise sound, but biquad filter didn't cancel out the noise, and the voice that being produced by the biquad filter still remain the same as the input. But we need to remember that notch uh, slower the voice from a little bit from the for the output. It is more slower than the input, but still we can hear it clearly. So filter design based on the title, filter design and application, we can uh, we can conclude that filters can be used in a lot of application, such as used for singing, used for telecommunications, and also used for voice recording. I think a filter is important in our daily life because it is used in a lot of application that we have been used in our daily life in this era. So that's all from us.